one. So the first one here we did, these were assigned yesterday. Hopefully you tried them. The first one has a common denominator. Wow, I was just in rationals. It doesn't have a common denominator. It's a common base. This one is a 2. This one is a 2. So if the bases are the same, what can we then say? This equals this, correct? Oh no. No, 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 no. No, 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 no. Right? No, no. Why? It's freezing. It's just on its way to freezing. It's fine today. Okay, base 2, base 2. Need a marker because it reset itself. Awesome. Okay, base 2, base 2. So then we get 5x plus 2 equals 17. Subtract 2. 5x equals 15. Divide by 5. X equals 3. Then do I send it and hope I'm right? No, you can check it algebraically. Guess what? You can also check it graphically. So I'm going to teach that to you today. Go to your calculator. I'll have to pull a calculator up and my computer will freeze, but that's okay. We'll try it. I need you to put the left-hand side of the equation into y1 and the right-hand side of the equation into y2. So in y1, you're going to have 2 to the 5x plus 2. If you have the older calculators, 5x plus 2 has to go in brackets. So if you have a calculator where the exponent does not pop up, 5x plus 2 has to go in brackets, okay? If you don't do that, it'll give you an error. Pardon? Nope, you're just putting in the x. So you're just putting in the actual question. So in the left, you put in 2 to the power of, see, mine pops up, so I don't need brackets. But if yours doesn't pop up, you have to put brackets, so I'll prove a point. You don't need brackets if it pops up. I'm just proving a point. So we go 5x plus 2 plus 3 plus 2. And then you have 2 to the 17. So mine pops up, I don't need brackets. If yours doesn't pop up, you need brackets. Okay? Then we press zoom 6, go back to our standard window. What was the answer we were looking for? What did we think it was? What was it? It was 3, correct? So when I go to find the intersection of these two graphs, just so you know, I just need to make sure that I have, my window has the answer in it. So I'm between -10 and 10. Is my answer fall in there? Yeah, so it's good. If my answer was 26, I would have to make sure that it would be between, that 26 would fall in my x's. So now I just go second, trace 5, enter, enter, enter. Here's my answer, 3. Move on happy, correct? Second trace 5, enter, 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 3. Now, if it errors you, it's because your answer is not in the window. You just have to make sure your x max and min contain the answer. Okay, let's go to the next one. This was base 2, base 2. So I can set my exponents equal. I get 2 minus 3x equals 7x minus 8. I know immediately this is going to cause problems because there's an x on both sides. But we've talked about this already. If there's an x on both sides, we spend no more than 1 second deciding to move an x. Correct? Pick one and move it. So I'm going to move this one because I saw it first. That is literally my reasoning. So 2 equals 7 xylophones plus 3 xylophones. 10 xylophones minus 8. Then we're back to junior high math again. Add our 8. 10 equals 10x. Divide by 10. And x equals 0 because it canceled off. What is this slanted line when it cancels? What is that, Jess? A really large 1, not a 0. So type this into your calculator. y1, y2, let's go. Bless you. y1, y2, you go. My calculator's spinning. Remember to put your exponent in brackets if you have the older calculators. So you're going to put in y1, 2. You're going to put this one into y1, this whole thing, with an x. This one into y2. Second trace 5, enter, enter, enter. And you should get x equals 1. Then you know you're right, and you move on.
Zero or is it one?
People will put 0 because they think when it cancels off it's 0, but when you cancel a slanted line, is actually just a 1, right? It's not a 0. Because like 4 divided by 4 is 1, not 0.
Yeah.
Okay, C. We need to make common base. What common base do we make the both of these? Let's make it be a smaller base. Base 9. This one's done. 9C plus 1. What's 729? 9 to the 3. So we have base 9, we have base 9, they're the same. So if these are the same base, then I can say that this exponent equals this one. So I get C plus 1 equals 3. Subtract 1. C equals 2. And then I can y1, y2 again, correct? Okay, let's look at D. What base can I make them both be? Base 5. We always make them be smaller. This one stays because it is already 5. 25 is 5 to the what? 5 to the 2. And an A. When you have one base, two exponents side by side, what do you do with those exponents? What do we do with the 2 and the A? What operation? Multiply. Remember, two bases that are the same two exponents, you add 1 with 2 exponents, multiply. So now I'm going to get 4A plus 2 equals 2A. And then what do? Subtract 4A. And I get 2 equals 2 apples minus 4 apples is negative 2 apples. Then how do I get A by itself? Divide by negative 2. So A equals negative 1. And we can y1, y2, we can plug into our calculator. We can take that negative 1 and plug it into the equation, the original typed equation, and see if left side equals right side, correct? If they ask us to check, we have to do it that way algebraically. All right, E, I have a 2 and a 64. What can I make them both be? 2 and a 64, what can I make them both be? 2. So this is 2 to the negative t. 64 is 2 to the what? 6. So now I have the same base, so then I can say negative t must equal 6. How do I get t by itself? Divide by negative 1. So t equals negative 6. Okay, we're looking at 10 and 1,000. What base can I make them both be? 10. So 10 is 10 to the 10x minus 2, and then this one is 10 to the 3. And I make sure I put this exponent in brackets because it's a binomial, so that I remember to distribute the 3 through. So, let's distribute it through. We get 10 to the 10x minus 2 equals 10 to the 60x minus 126. We agree? Yeah? Okay. If this is base 10 and this is base 10, then I can say that this must equal this. Remember we did it yesterday? If I had 10 to the smiley face equals 10 to the 6, you would tell me, oh, smiley face has to equal 6 then. Correct? So it's the same thing. If your bases are the same, then your exponents must be equal. So now I have 10x minus 2 equals 60x minus 126. Once again, the conundrum of x's. Pick one, move it. Correct? So I'm going to subtract 10x because it was the first thing I saw. That was literally my reasoning again. So I get negative 2 equals 50x minus 126. I'm going to add 126. And I get 124 equals 50x. Then what do I, yeah.
I just have a question about the, how, shouldn't it be 6 though? instead of -6 is 2 to the power of -6.
You're going to put -6 into t to the negative t. So it's going to be, sorry, 2 to the negative t. So it's going to be 2 to the negative -6, which is 6. Yeah. Okay, this one we're going to divide by 50.
8.
And what is it reduced to?
2.48.
Now enter, enter. What is it reduced to? Because that's a rounded decimal.
62.25.
Does that work to a, sorry, a terminating decimal? Was it a stopping decimal?
Yes.
Okay, what was it?
2.48.
Okay. So are both of them acceptable? Why? Because 2.48 is what it equals. If you do a rounded decimal, say it was like 2.479, blah, 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 and you went 2.48, is that actually what it equals? No, that's a rounded answer. It's an approximation. So if the decimal terminates, you're allowed to use it. Okay. G I didn't make you do, but I'm going to now. All right. So we have 2, 16, and 2. The catch here is the root 2. Let's talk about that. Grade 10. Square root of 2. Your teacher taught you in grade 10 how to convert these to rational exponents, and the reason why they did was for this very moment. So, what is the exponent on the 2 if there's no exponent? It's a 1, correct? What is the number in the index? The index is the number that sits here beside the radical. What is that number if there isn't one? It's a 2. Your teacher taught you that. What you can do is actually just bring that underneath the exponent and rewrite it. And it gets rid of the radical. It gets a rational exponent. So I can get this. This is actually equal to 2. The exponent stays there, and the 2 just drops underneath to the 1/2. Type in your calculator, root 2. You get a crazy decimal, right? Then type into your calculator 2 to the 1/2. If you have the older calculators, 1/2 has to go in brackets, or your calculator doesn't know that it's a fraction. Remember, the old calculators, the only way it knows it's a fraction is if it's in brackets. Are they the same decimal? Yes, because they're the same thing. So what if I would give you this now? This is not the question, but say I gave you the cube root of 4 to the 2. What could you rewrite that as? 4 to the 2/3. That's it. It was a lesson that was like mind-blowing in grade 10 that no one could actually do. They're like, I have no idea what you were doing. Like, we're just literally just putting that number underneath. That's it. Okay? So if I have root 2 on my previous page, then I can write that as 2 to the 1/2. Can I not? We agree? So let's go back here. This is 2 to the x equals something, and then 2 to the 1/2. Because root 2 is 2 to the 1/2. Yes? We just discussed that. 16 is 2 to the what? Because we also need it to be a base 2. Yeah?
2 to the 4.
2 to the 4. So now on this side I have 2 to the x. In this side I have 2 to the something. Let's talk about it. Same base. 2 bases that are the same, 2 exponents. What do I do with those exponents? Add them. Right? You can only put together bases that are the same. And then you can put them together by addition. So it's going to be the 4.5, right? 4 plus 1/2 is 4.5. So what does x equal then? 4.5, that's it. Okay, H. H and I you're going to try if you haven't tried them yet, but I want to discuss them. Why are H and I a little harder than the above ones? Because the above ones, one of them was common base and the other one I had to make common base, correct? 8 and 4. Is 4 a common base to 8? No. What's the common base to 8 and 4? 2. So you actually have to change them both to 2's. And what about I? 9 and 27. What's their common base? 3. So you have to change them both to 3's. So try those two out. I know I assigned them yesterday, but try them again. Oh, I didn't. So 8 and 4, we can make them both be base 2. 8 is 2 to the 3, to the 3x, and 4 is 2 to the 2, to the 1 minus x, and then we distribute through, so we get 2 to the 9x equals 2 to the 2 minus 2x. And often people forget to distribute through, so don't forget that. Now I have base 2, so I can set these equal. So now I have 9x equals 2 minus 2x, add 2, and I get 11x equals 2, and then I have to divide by 11. So x equals 2 over 11, done. We can make them both be base 3. So here I get 9, which is 3 squared, to 3x plus 1. And then here I get 3 cubed, with a 3x. I have to remember to distribute. So I get 3 to the 6x plus 2, to distribute through, equals 3 to the 9x. Base 3, so I get 6x plus 2 equals 9x. I have to move my x's together. Which side's better on this one? Move it to the right, correct? Because then you have the number on this side. But if you don't, you'll set it equals 0 and you'll have to just move your number or your variable. So I'm going to subtract 6x. 2 equals 3x. Divide by 3. X equals 2/3. Okay, last one we're going through. We talked about this one yesterday when we were making common base. So we have 4 and 7. We have 64 and 343. And some people get overwhelmed at that. But remember, the 4 can be made in the 64. Sorry, can be made into base 4. Correct? So we'll look at it partly. We're going to leave the 4 over 7 to the 5x because that one's in the lowest form. But 64, I want it to be 4 to the something. 64 is 4 to the what? 3. 4 to the 3. Now I hope that 7 to the 3 is also 343. Is 7 to the 3 343? Yes. Yes. So can I write 4 over 7 all to the 3? And that would get me 64 over 343? Is that true? Yeah. 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 Who are you finding out there?
I'm not finding anyone.
You looked out there then asked. I feel it's a little sus right now. That's okay. Anyone else feel some susness happening right now? I do. A little bit of susness. 4 over 7. I kept like that. Get my own new word, susness. 6x minus 3. Yo.
So if, like, because the 4 was to the 3 and the 7 was to the 3, if you had another instance where both the numbers, like, say one was like 7 to the 2, but then the numerator was like 4 to the 5.
They couldn't ask it in a common base question. Yeah. So now our bases are the same, so we can set our exponents equal, and we get, that to go away, we get 5x equals 6x minus 3, and now this one's subtracted to 6x. Should be better. So we get negative x equals negative 3, divided by negative 1, x equals 3. Can I check these by typing them in, y1, y2? Every single one of them, correct? Or I could take the answer and plug it back into the original, right? Every single time. Okay, we're going to flip over then. We're going to go to a word problem just to show you how we can use this actually in a word problem. So much stuff going on here. We're going to go right here. We're going to look at example 3. A bacterium triples every 6 days. The number of bacteria, N. So the number of bacteria is represented by N. So if I know the number of bacteria, I'm going to put that in for N. Is present after X days. So if I know days, I'm going to fill it in for X. If I know number of bacteria, I'm going to fill it in for n. Let's see what we have here. So this is my formula. It is n equals 3 to the x over 6. Let's see what they gave me. After how many days, so do they want me to find x or n? How many days? X. Are there 243 bacteria? What did they give me? N. So now I have 243 equals 3 to the x over 6. Is that true? Now the only way we know how to solve currently is common base. So 243, I'm going to try and figure out if, hopefully, it's 3 to the something. Does anyone know what 243 is? Yeah?
3 to the 5.
3 to the 5. So I'm going to get 3 to the 5 equals 3 to the x divided by 6. So now I have base the same. And then I can say that this equals this. So I get 5 equals x over 6. And x over 6 is a fancy way of saying, there's a lack of fancy way, I guess, of saying x divided by 6, correct? And I need to move a division of 6. How do I move a division of 6? Multiply by 6. So I get x equals 30. 30 what? 30 penguins, 30 potatoes, 30 days. And then I'm done because I have the answer and I boxed it, even though it's a written response. Mrs. Lepp would like crumble inside a little bit. What do we have to do? Write a sentence. After how many days are there 243 bacteria? After 30 days, there are 243 bacteria. Oh, what does this one say? Your turn. I'm just going to have you do A, okay? Try it out. Oh, I keep pressing the wrong thing. Camera. So this one has 256 bacteria and it's doubling, so that's why there's a 2 instead of a 3. Every 12 hours, the 12's on the bottom. So we have 256 equals 2 to the h over 12. 256 is 2 to the what? 8. 2 to the h over 12. 8 equals h over 12 times 12. 12. H equals, that's a 12. H equals what? 96 what? We box it, we're done. Mrs. Lepp is sad. That's where we are. How many hours are, after how many hours? After 96 hours, there are 256 bacteria. Okay, then we're going to flip over to the next lesson. Right there, just about flipped over and then didn't make it back. That's what would have happened. If I flipped, I'm not coming back to broken things. Just call 911. If ever I flip. It will not be intentional. All right. We're converting between logs and exponentials and logs. First off, if they ask us to do it, we do it. But second off, the reason why we do conversions is because we are asked to, or we have to solve for a variable that's locked in. Okay, everyone paying attention. The word log is short for logarithm. It's a button on your calculator. It is the inverse of exponentials. That's why they go hand in hand. So what we're going to try and do is convert all of these here, convert each of the following from logarithmic form to exponential. Okay? The only way you can convert is if there's 3 pieces of information. Look here. 3 pieces of information go in 3 pieces of information's different spots. Right? You see that? If there's more than 3 pieces of information, we have to do something first in order to be able to convert it. Okay? Now there is a formula on your formula sheet that shows you the conversion. If you forget, It is a double-headed arrow because it goes in opposite directions. What I always do is I always just look for the base of my log or the base of my exponent first. Okay? So, right here is the base of my log. See this? This is the base of my log. That number that's at the bottom is called the base of your log. It will become the base of your exponent. Do you see how there's an exponent there? The base of the log becomes the base of the exponent. That's the easiest thing to do. So let's look here. What is the base of my log in this one? 7. What's the base of my log here? Now, with a square root, the index is a 2, but we don't write it, correct? We don't have to because it's the most commonly used root, okay? Logs, the most commonly used log is log base 10. Because like Richter scales and stuff like that are in base 10 magnitudes and such. So are pHs are base 10. So logs, the most common one is base 10. So that's why when there is no base, it is base 10. So you can fill in a 10 there. Just like when you look at a radical and there's no index, that number above the radical sign, it's a 2. Okay? So this one is base 10. What's the base of this, of C? 5. What's the base of D? It's a T. It's just variables. And then this one is how many pieces of information? 1, 2, 3, 4. Do you see that? The 3, the 4, the x plus 2, and the 9, that's 4 pieces of information, and I'm only allowed to have 3. Does anyone know how I could move something, possibly? The 3. How can I move it? Oh. Divide. Divide the 3 over. Now I have log base 4 of x plus 2 equals 3. Now do I have 3 pieces of information? Yes, I'll be able to convert it. What's my base? 4. Do you stack on the base of all my logs? Everyone agree? So A's base is 7, B's base is 10, C's base is 5, D's base is T, E's base is 4. Yeah.
Sorry, for B, how'd you get it?
Because the most common base for logs used is 10. So whenever there isn't a base, you put base 10. Okay? Yeah. Are you going to the bathroom or are you getting a sandwich? Okay, just checking. Just clarifying now. I'm a little afraid of the susness that exists. All right. Okay, so we know that the base of the exponent will be all of those bases. We agree? If it has a log in it, it's going to convert to exponential, because that's the opposite of it. So are you watching? The base of my log becomes the base of my exponent. Now, that is a base of an exponent. I need an exponent or it's not a base. Do you see how the 7 and the x are besties currently? They don't stay besties. They swap. So when a log becomes an exponential, the besties swap. So what's the 7 going to have for its bestie now? Its exponent. It currently is its bestie. 4. What is its bestie currently will not stay its bestie, right? So 7's bestie is x. You see that? Okay. What's the base of the next one? 10. What's going to be its exponent? 4. Because what's besties doesn't stay besties. Correct? What's the base of C? 5. It's going to need an exponent. What's its exponent going to be? Y. What about this one? What's its base? T. What's its exponent going to be? M. What's this one's base going to be? 4. What's its exponent going to be? 3, because it's bestie doesn't say bestie. Do you agree? Now just equals the other one. What's left over? This one's going to equal x, because that's what's left over of the 3 pieces. Correct? What's this one going to equal? X. What's this one going to equal? 15. What's this one going to equal? B. What's this one going to equal? X plus 2. Just the third thing. So if you always start off with the base of your log as the base of your exponent, it's a really easy conversion after that. Because what's friends doesn't stay friends. That's what I always do. Base of my log because base of my exponent. What's friends doesn't stay friends. So I get the other thing. And then it equals what's the third piece that I have not used. Okay? Try it out. F, G, H, I, J. Go. Oh, I keep pressing that. Okay, what's the base of this one? Base is 6. So I start off with that. What is going to be its exponent? 2. What's left over? X. Not too bad, right? Okay, what's the base of this one? It's base 10. Remember, if it doesn't have a base, it's base 10. How many pieces of information does this one have? 4. So what do I need to do first? Divide by 3. So I'm going to get 3 equals log base 10 of x. And I'm going to tell you right now, if a log doesn't have a base, the very first thing I'm going to do is put a 10 in that spot. If not, I might miss it. Okay? So the base of my log on this one is 10. It needs an exponent. What's going to be its exponent? 3, because what's besties doesn't say besties, right? So 3. And it's going to equal x. H, what's its base? 3. So that has to be immediately the base of my exponent. Now, it can only be the base of an exponent if it has an exponent, correct? That's why I immediately go to an exponent after. Because it can't be a base if it's just a number sitting there. So it's the base of my exponent. What's going to go with it as an exponent? Y. And then it equals what's left over, which is 27. Okay, I, what's its base? X, so that's going to be my base. What's Bessie's going to stay Bessie, so it's not going to stay with a C. What's the exponent going to be? P. Then it's going to equal what's left over, which is C. What's the problem with J? There's 4 pieces of information, and I can't start to convert unless there's 3. So what's the first thing I'm going to have to do? Divide the 4 from both sides. And I get log base 4, 2x minus 1, equals 4. Okay, what's my base here? 4. What's the exponent going to be? This one, right? And then it's going to equal what's left over, which is? Perfect. Now, if we remember those rules, it doesn't matter if we convert back to a log. The base of my exponent becomes the base of my log. What's friends doesn't stay friends, right? It's the same rules. It doesn't change. So I'm going to convert each of these from exponential to a log now. Well, in order to convert to a log, I need to have the word log. So that's my first step, right? If I don't have the word log, it's not a log. Okay, bases stay bases, right? So what's the base of my exponent here? 4. Do you see it? The base of my exponent. It's going to go in the base of my log. Do you see how I'm doing that? Base of the exponent becomes the base of the log. Same spots. Now a log always has to have something beside it. What's going to go beside it? 64. Why? Because what's friends doesn't stay friends, right? What's friends doesn't stay friends. So if you put your base in immediately, that one's done. I always circle it. Then what goes beside it is going to be what's not its friend currently. And then it's going to equal x, what's left over. So the first step when converting from exponential to log is write the word log. Okay? So B, I have 1, 2, 3 pieces of information. So I can convert. If I have more than 3 pieces of information, I'm not allowed to convert. Okay? So I can convert. I go log. What's the base of my exponent currently? It's the 3, so it's going to go in the base of my log. Do you see that? Bases stay bases. Yes? Okay. I need to have something beside my log. Friends switch. So it can't be the x plus 2. It's going to have to be the 20. And then it's going to equal x plus 2. Okay, see is where life gets real rough. When we had that extra piece of information in the previous questions, you guys divided it over, right? Genius-like. Now, instead of dividing the 3 over, you guys are going to try and make it join the 5. Do you think they'll have that on the test as an answer? Yeah, it's totally wrong. Watch this. If I have 2 to the 6 times 2 to the 7, I get 2 to the 13. Because I need to have the same base, then I can add exponents. We agree? So if I have this, everyone paying attention? 2 times 5 to the x. Can I put these together as 10? I can only put them together if it was a 2 and a 2. Is it a 2 and a 2? No, so I cannot do that. It is illegal in all states, territories, provinces, and Mars. I swear, I talked to them. But they would agree. All right, so I cannot make the 3 join the 5. So Slack would kind of be like, stop it, because you will try and do that. You will try and do that. What should you do instead? Divide the 3, just like you divided last time, right? You divide again. It's no different than the previous ones. So we're going to divide by 3. And I'm going to get 5 to the 2x minus 1 equals 4. Now do I have 3 pieces of information? Yes. Can I convert? Yes. I'm going from exponential to log. People are like, I don't know if I'm going from log to exponential or exponential to log. Does it have the word log in it? No. So you're going to a log, correct? Because one has the word log and one does not. It's very easy to tell. So first thing I do is write the word log. Then I put in the base. What's the base? Base of my exponent is 5, so the base of my log is 5. Something has to go beside my log. What's it going to be? The 4, because it's besties doesn't say besties, and it's going to equal 2x minus 1. What's the problem with D? It's 4 pieces of information, so that 3 is my problem. Can I make the 3 and the 4 join and make it a 12? No. It's awful. Don't do that. What do? We divide the 3 over instead. And we get 8 equals 4 to the x minus 1. Now I have 3 pieces of information, so I can convert it to a log. Okay, I need the base first. What's the base of the exponent? 4, so that's the base of my log. Besties doesn't say besties, what's going to go beside it? 8, and it's going to equal x minus 1. What does this say? So it's your turn, go. I want to get this done before the end of class, so go. We need to convert these. Log base what? Log base 5. What goes beside it? 125, and it equals 2x. 3 pieces of information again. Log base what? X. What goes beside it? 36, and it's going to equal 3. Problem with G? 4 pieces of information, so I'm going to divide the 4 over. 9 to the 3x minus 1 equals 6. Okay, I'm circling the wrong thing. Base. Log base 9 of 6 equals 3x minus 1. And then the last one, log base D. What goes beside it now? F, and it equals 8. Good. You did your homework during the class.